Hi guys, in this presentation we shall learn more about pointers. See here, there is a character, integer, float and double. So we use these data types to represent different types of data. For example, if we need a large set, then we will go with int. Okay, if you want to get a real data, then use float and double or whatever. So my point is, for different data we are using different data types. So here is the so that's why here different data types are used. Now here, since the pointer is of same size, like in my previous lecture I already said that pointers occupies same size. In my machine it occupies 8 bytes of memory. So if it occupies 8 bytes of memory, then why we should write character int float and double? See here, if you write character int float and double, it represents something, right? It represents 1 byte, it represents 4 byte, here also 4 bytes, here 8 bytes, and here the format of storing the data is different. Okay, but in this case here the pointer is nothing but the address, right? So address is same. So what is the use of writing character int float and double? Okay, so this is the question. So before answering this question, we shall see some example. I have a variables declared here. After that, here you can see that the address is stored in the pointer. Okay, so I printed the pointer, and what is the value if I increment the pointer. So let's compile and see what will be my answer. You can see here character size. See here the address is 64F. If I increment 1, then I can see here 4F means after F0 will be there. So after F10, so 1 will be there. So 64F, if we increment 1, then we'll get 650. Yes, it's pretty simple, right? If you know the hexadecimal system. Okay, now here integer, you can see that here 650 is there, but after increment I got 654. Okay, and then see here also, here 654 is there, after increment I got 658. Here 658 is there, after increment I got 660. So first case is valid, okay, as expected it's working, but why second, third and fourth case are somewhat different? See here, here the difference is 4, here the difference is 4, here the difference is 8. You can see here, right? See 58260, you can see here 59, 5a, 5b, 5c, 5d, 5e, 5f and 60. So total 8 bytes are here differences. Okay, so my question is why this is happened. So before understanding that, let's focus in this case. If you understand this case, then these two cases are simple. Okay, for example, if I have a character array of 4 bytes, which means that 4 bytes are allocated in the memory. Okay, in this fashion, and I have stored some value like 1 1 2 2 3 3 4 4. Okay, so what I'll do is character star a should equal to ampersand of array. So what this means is, whatever the array's base address. Okay, so what is the array's base address? This is the array's base address. Okay, so this is stored in this pointer. So in pointer a, 100 is stored. 100 is nothing but the address of this array. Okay, now if I increment it, then it should point to this location. Yes, it's working, right? If I increment the value, I'll get 101 location. If I increment the another value, I'll get 102 location. Increment 103 location, right? So it's working. So if I fetch the value, for example, see, if I say that star a, see star of a, what is the value contain? What is the value that contains in a? So value contains is 100. So 100 is nothing but the address. Okay. If you dereference it, the value will be 11. Okay. If I increment the pointer, then the value will be 22. So here array size is 4 and character allocates 1 byte. So there is no problem here. If you increment, we will get to next value. If you increment, we will get to next value. So now what happens in the case of integer? See, integer occupies 4 bytes, right? 4 bytes, and how many 4 bytes we have allocated? 3, right? So the total 12 bytes should be allocated. Okay, so you can see here 4 4 4 12 bytes are allocated. So this array of 3 represents array of 0 1 2. Okay, array of 0 1 2, and inside I have my data. Okay, for every byte there is an address. Now here the question comes, if I have an integer pointer in which I have stored the address of array, okay, so in pointer p I have value 100, right, that is here. If I increment this, if I'll get 101, then I'll get the value, I'll get the address from here, right? But remember one thing, whenever we allocate memory for the integer, by default it allocates 4 bytes, right? Okay, if the pointer points to here, then 1 2 3 4, these are all the data which is present in the array 0. Okay, for getting this data we have to increment it 4 times, right? From here I have to increment 1 2 3 4, so that's why there is an increment of 4 bytes integer pointer. Okay, if I want to fetch the data which is present in array 2, then what I'll do is I'll increment 4 times here, right? 1 2 3 and 4. From here I'll get the data. Now my question is, how it knows whether to fetch 4 bytes or 8 bytes or 2 bytes? It depends, right? See, if there is a character, then I have to fetch 1 byte. If it is an integer, I have to fetch 4 bytes, because this is the reason, right? Whenever you allocate memory, it is allocated in 4 bytes. Okay, the 4 set is considered as 1 in integer. Okay, if it is in 8 bytes, then that 8 set is considered as 1 set in double. Okay, now I know I have placed the pointer here, but who will tell whether to move up to here, up to here? So that is taken care by this. So you can see here it is an integer pointer which states that whatever the location you put, okay, for example, if I put the location here, I'll fetch the 4 bytes, 1 2 3 4. Yes, this is the wrong information, but this is how it works. So if I store the value 100 in this pointer, then I'll get this as data, right? These 4. If I place the pointer here, I'll get this as data. Okay, so that is why here integer pointer is used. If I use character pointer, then if I store the value as array, then now p contains 100, right? So now character pointer points to this location. If I increment, I'll go to here, another increment, I'll go to here. Okay, so it knows only how to, so character basically is of 1 byte of data, which means it will fetch the 1 byte of data, that's it. Okay, these are responsible to fetching the data. Okay, no matter what you give the address, from that address it will fetch the, if it is character, it will fetch 1 byte. If it is integer, it will fetch 4 bytes. If it is float, it will fetch 4 bytes, and if it is double, it will fetch 8 bytes. Okay, now you can see the relation between these and these. Okay, it will allocate 1 byte of data, it will fetch 1 byte of data. It will allocate 4 bytes of data, it will fetch 4 bytes of data. It allocates 4 bytes, again fetch 4 bytes, allocate 8 bytes, fetch 8 bytes. Okay, this is the reason why you use here character, integer, float and double. Okay, again I'm just repeating that, just to make you comfortable. See, example, I have an array of elements 2, which means this represents 0th element, this represents first element. So whenever there is an integer, it occupies 4 bytes, it occupies 4 bytes. Okay, no matter what you put in this here, either 0 or maximum value, okay, it is a one entity. Okay, so this whole entity is represented by 4 bytes. Okay, so since here 4 bytes are there, each byte has location, right? So in this location some value will be there, in this location some value will be there, in this and in this, right? So this whole entity represents the integer. Okay, so that is the reason why when we increment this address, it will go to here, because when we increment, we want to get the second entity, right? For example, if I store here like array of 0 100 and array of 1, I stored 200, then here I stored 100, here I stored 200. If I want to get the value 100, I'll use this pointer and fetch 4 bytes. Okay, if I want to get the 200, I'll increment this pointer and fetch 4 bytes. Okay, the fetching part is done by the pointer. Which pointer? Integer pointer. Because integer pointer, it knows that whatever you give me the address, I will fetch 4 bytes from there. Okay, you can see here array of 3 elements in which each element has some values, okay, which I have already discussed in the previous slide. Now here I have taken I as an pointer, right? So integer pointer. Okay, now this integer pointer, it knows that I have to fetch the 4 bytes. Okay, if I increment, I have to go to the plus 4. Okay, plus 4 address. Now you can see here, what I have did is, first I have printed the value and the address, and incremented value address and incremented value address. Just print and see what will be the answers. First I have stored 1, and next 1 2 3 4, and next 1 1 2 2 3 3 4 4, right? So these are the values. In order to get the values, see here, since 4 bytes are allocated, here it starts with 0, and the next value, it starts from f4, and the next value will start from f8. Okay, so it is working, right? So what happens if I want to fetch in between bytes? For example, if I want to fetch this data, only this data 12, so what can I do? So we have to use some logic. See here, we know that if I want to fetch only 1 byte, then I can use character pointer, right? So I can use like character pointer, in which I can store this address, right? So I can write like address of 1. So in pointer p, I'll have value called 104. So we know that if I increment the character pointer, I'll get the address 105, right? So what I'll do is I'll increment the pointer. So this value will be updated with 105. Now I can fetch the data, right? So I can print star p, I'll get the value 12. So what I did now, so what I did is, see, no matter what the address you put here, no matter what the address you put in this, okay, if it is a character pointer, then we'll get the 1 byte as data. Okay, for example, if I put 0 here, I'll get the value as 0 1. If I put here 1, then I'll get the value as 34. If I put 2 here, I'll get the value as 44. So what I've written is, I have written a program, okay, in which I'll print all these values, okay, and I want to show you. Okay, just I want to make sure that you understood the concept very well. I have already declared an array, okay, in which all these data are there. Okay, now if I read the data byte by byte, then I can get the answer like 0 1 0 0 0 0 and 0 0, right? Here 3 4 2 1 0 0 0 0, here 4 4 3 3 2 2 1 1, right? So let's see here. See, what I did is, here I have an address which is stored in the pointer p, right? Now this is the base address of the first element. Okay, now what I did here, see, this is the base address. After that I incremented one time, second time, and third time. So total 1 2 3 4. So 4 locations, and what are the locations? So what is the value in that location is dereferencing, right? I have dereferenced it. For the same, like I have written for, you can see here is array 1 and array 2. So array 1 base address is stored in the same pointer, same and same story. Increment the pointer, printing the all values. So whatever I stored in the array, each data will get displayed, right, in form of bytes. Let's see. You can see here is the base address, right? If I fetch this data, I'll get the answer as 1. You can see answer as 1. So after that, if it is incremented, then this is the data 0 0 0 0, again 0 0 0 0 0 0 0 0. So anything, any value, no matter how many zeros you put, the value will be 0, right? So you can see here, this is stored in 1 byte, 1 byte, 1 byte, 1 byte, total 4 bytes are there. You can see here 40 41 42 43. Okay, from this to this, the difference is 4. You can see here from 40 to 44, the difference is 4, and the second element stores from here, right? 3 4 3 4 and 1 2 1 2, again 0 0 0 0. So you can see the addresses also. So last I stored that 4 4 3 3 2 2 1 1, right? 4 4 3 3 2 2 and 1 1. Okay, so now you can relate these with this. Okay, see how we stored the values and how retrieving the values. Okay, so while incrementing the pointer, it depends on what pointer it is, right? If it is a character pointer, it is incremented by 1. If it is an integer pointer, then it is incremented plus 4, right? So plus 4 for float and plus 8 for double. Okay, so it depends on what type of pointer we are using. Okay, so that is the reason why in the early slide as I have shown you that while incrementing, the character pointer is incremented one time and integer pointer is incremented four times. Okay, now so how many bytes we have to fetch, that is also decided by the pointer only. Okay, if it is an integer, then it will fetch 4 bytes. It is in character, if it is in character, then it will fetch 1 bytes. Okay, so it depends on the what type of pointer it is. Okay, I hope you understood what I said.